The objective here is to demonstrate the ability to think step by step. And the way we'll do this is by going to this website, logointerpreter.com/turtleeditorphp. And once there, you'll see this little turtle guy. Your job is to type in commands right here to get the turtle to move in the way you want to. One of the things I like to do when I get to a new website I've never used is just kind of click around and to experiment with things, see what happens when I'm like clicking. I can change the line width here. It was 1, so now I could make it 3, so that's kind of cool. If I go over here and push the rocket, nothing is happening. That's actually because I haven't typed anything here. If I go over here to the eyeball, I can hide the turtle and show him. I don't know what that button does. Oh, it makes it the line invisible. Cool. And now that I've been clicking around, I actually see the commands over here. So if I click that button, okay, so pin up and pin down is what that stands for. In programming, you'll see constant acronyms or the short forms of words all over the place. Alright, so let me get rid of all this. I do that by clicking reload here. And it looks like all that happened is it put those commands down here. So if I control A and backspace, I can have a clean slate. So let's go over here and just discuss real quick. Why are we moving a turtle around in a coding exercise? Well, programming itself is very systematic. You see this step-by-step part? This is to be taken literally on your journey to learn how to program. Basically, you say a command, and you usually have a value next to the command, and that will result in action. Another way to look at this is you put in an input, and there's an output. Over here, our code will go here, and then we push the little rocket, and that'll be the input the program needs in order to draw the drawing we're about to see. On your phone, when you press the button to turn it on, that input of the button press tells the computer to turn on all those lights. And speaking of buttons, that's all these commands are actually connected to. As we write our mini program over here, in real life or in the next steps that you'll take to better learn coding, you'll actually just be connecting these commands with the buttons, and you're going to see pretty soon here that by doing so, you'll have the beginning of a game. It may not feel very impressive to just move a turtle around, but when you push a button in a game and move your character, or you hold down the joystick in one direction, that is a constant input, or just an input if you moved it in one direction really quickly, and that is what a game is. So let's start with me. I will first demonstrate how to make a triangle, and then I'm going to do something a little crazy and make a chessboard. And as you saw, you can actually use other tools, pin up, pin down. You can make some really complex, cool things here. But let's start small. I want to make a triangle. And since I don't really know the commands for that, let me just make it with the buttons up here. So I will not go straight because I want my triangle to look like this, if you can see my cursor. So I will turn slightly. So I took a right turn by 45 degrees. I'll move up. Let me do that again. So another right by 45. That didn't work. So I'm going to go right again by 45. And then I'll go forward. I'm already almost there. So if I go right and right again and right again, so 3 45s. Just visually, I see the turtle is in the right direction. Now there's a problem. I went 50 pixels over, but it's not connecting to the line. So I'm not very good at math. I always tell my students you don't have to be good at math to be a good programmer. So I'm going to go over to Google here and just type in, well, once I started typing in calculate the longest side, the triangle thing popped up. So I found this triangle calculator, and all I did is put in the right values that I was using. So there you go, 90 degrees up here. Each side was 50 and then 45 on the sides. The only reason I had to do 3 45s here is because that turtle guy was just facing in the wrong direction. But if I go down here and click that little angle thing, I could see what makes a right angle a little bit better with that. But anyways, I see the number 70 here. So instead of moving forward 50, well, let me just round down a little bit. I'll move forward by 20 more. And that actually looks good. If I not pick up the pin, if I make the turtle invisible, that's a perfect triangle right there. All right, let me pivot here and make a bigger triangle. So I'm gonna go over here, I'm gonna copy all of that, reload my program. Oh, I didn't need a copy, it came down here. Okay, so without pushing anything, I'm gonna think the turtle turns right, and then he moves forward by 50. Let me make that maybe 500. I'll test the code real quick, see if that's too insane. That's too insane. Okay, so reload. Here we go. Instead of 500, I'll go with 100. That should be good. Test real quick. Okay, I need more than 100, so I'm just going to try again. Let's turn that into 2. All right, that should be good. And then instead of being silly and doing right 45 and 45, let me just type 90. And then I'm gonna go forward 200 again. And then instead again being silly, this should be 135 if I can add numbers correctly. And now I'm gonna go back to my triangle calculator to see what I need. Okay, so 90 degrees, 200, 200, this should be enough. And then I'm gonna hide turtle, HT for hide turtle, just to get a better view. All right, go to my rocket, launch the program. Not bad, it's off the screen, but at least it's correct. If I wanted to fix that, I could reload, I could go up here, I could lift the pin up. Uh-oh, Control Z to undo, that doesn't work, all right. Oh no, I thought I deleted all my code for a second, but then there's this undo button, so PU to lift the pin up, and then I'm gonna have him turn to the left and scoot over a little, and then I need him back in his original position so he can actually draw the triangle. So pin up, left turn by 90 degrees. See, this is the hard part of coding, imagining what's going to happen next. Then I'm gonna move forward since he's turned in the other direction. Let's move him over by 100, that should be good. And then I'm gonna have him right turn 90 degrees to put him back in his original position. So in my imagination, everything's working out. Let me run it to see if it works. It does not. So what's the problem? I forgot to put the pin back down. So delete the extra PU, and after he turns right, I'm going to pin down. Run the program. Looks great. If I wanted to optimize my code, I can actually change this a little bit. So instead of putting the pin down here, let me just delete that. I'm gonna add 45 degrees to 90. So that should be 135, and then I'll put the pin down, and let's see if I optimize the code correctly. All that means is I use less lines. I got 11 lines here instead of whatever I had before. So if I run it, okay, looks great. Now let me show you the repeat command, and then I'll give you your 2 assignments. A regular simple task here, and then a challenge. So I'm gonna make the chessboard, and after I do that, you create a little 4 square like you'd see on an elementary playground. And my challenge, especially practicing code optimization, I wonder if you can create a hopscotch design or grid like you'd also see on an elementary playground, and doing so in the fewest amounts of lines of code would be great. Okay, so let's create a chessboard, and the cool thing about doing so is you'll get to see the repeat command. But the turtle's in the wrong position already because I want to make the chessboard pretty big. The cool thing about coding is code reuse. So let me go back to get the guy to move up. So I did pin up, he turned left, he moved forward, and then he turned right by 135 degrees. I'm going to just, oh, I need to put the pin back down. I'm going to just copy that and reuse it. Okay, so let me run the program. Uh-oh, that's not what I want, so I messed up on the degrees. So reload. There we go, 90 degrees is what I want, so he's in a better position to make the chessboard. Okay, reload. So just in my imagination, how does this work? So if he goes forward 50 and then takes a right-hand turn, 90 degrees, and he does that over and over, he'll have a square. So how many times does he need to do that over and over? 4. So instead of writing these 4 lines of code, which is a lot, I'm going to save myself some keystrokes and show you a trick. We're going to just say repeat, square bracket, forward 50, and then right 90. I'm not too happy about the syntax because usually in programming languages you always see the comma, but that just breaks the program if we try. So anyways, let's run our program, see if it works, and there we go. I have a square. So in order to make a chessboard, which is 64 squares, how can I use a repeat command within a repeat command? So here's my idea, and it didn't work. So let me show you some debugging tricks here. If I reload, this didn't work, and that's because of the position of the turtle actually. So how did I know this? Well, for me it was just experience, but for you guys to debug using a system like this, a website like this, if you move the slider down and then click this animate, it'll slowly show you the code executing. So he just goes in that same circle and he does it 65 times. I notice an error right there on my part, so let me reload. Oh, I have to push the X apparently. So I'll reload, change that to a 4, and I need to change his direction he's facing at the very end. So I have to imagine this. Going forward, right, down. Now he's facing this way. He's not supposed to take a right. Okay, so I'm going to move this down. We're going to repeat this block of code 64 times. So after he does this square, I want him to turn again. No, I don't. I want him to move forward by 100 and then make that square again. So let's test. Whoops, I have one too many brackets, so backspace. Attention to detail is the key to coding well. Okay, and that looks crummy, and that's not what I want. So try again. Reload. Oh, I moved forward 100, so at least there's one solution. Let me get one part of my solution going. Okay, that's better, but I need, what, an 8x8 square, so let's reload. Okay, don't repeat this 64 times. Let's repeat it 8 times and just see what that looks like. Okay, and that's just too much. This chessboard is gonna go off the screen, so let me not move forward 50, maybe 20. So let's create some really small squares. Okay, that looks better. So after he does that 8 times, I need him to move over and create another one and another one and another one. So reload. And you know what? How about instead of me finishing this one up, that's your other challenge. So I want you to make or finish the chessboard. Maybe before you do this, let's actually create the 4 square I'm asking you to do. Maybe what you do here will help you over here. And just so we're all on the same page, I'm just looking for 4 squares next to each other like that. And then as an additional challenge, so after you do the square, the chessboard, let me see a hopscotch design like that. So with all that said, I hope this video helps you understand a website like this. But for now, I think this is a good first step in learning how to think step by step when you're programming.